Introduction of Rural Sociology and Educational Psychology Intelligence by Dr. Saurabh Sharma, Associate Professor, Nagaland University, Medzifema Campus, Nagaland. Intelligence in agriculture. Intelligence means the ability to learn, understand and use knowledge and skills to solve problems and adapt to new situations. Or, intelligence means how well a person can learn, understand and solve problems. What is intelligence? Thorndike: the ability to make profitable use of past experience. Binet: the ability to adapt oneself, to judge well, understand well, reason well and act well. Weschler: the global capacity of an individual to think rationally, act purposefully and deal effectively with their environment. Gardner: the ability to respond successfully to new situations and the capacity to learn from one's past experiences. Intelligence is what makes humans unique among species, our ability to reason, adapt, learn from experience, and apply knowledge to new situations. 3 types of intelligence according to Thorndike. Intelligence manifests in 3 distinct forms. Abstract intelligence: it means being good at understanding words and numbers. Example: a student solves math problems and explains them clearly in class. Mechanical intelligence: it means knowing how to use and work with things around you. Example: a student fixes a broken toy by using simple tools. Social intelligence: it means knowing how to interact with people and handle relationships well. Example: a student helps settle a fight between classmates by talking to both sides calmly. Theories of intelligence. 1. Connection theory or multi-factor theory. Thorndike: intelligence means how the brain connects actions and reactions. A person can be good at studies but not so good at making friends. This idea is called multi-factor theory. 2. Two-factor theory. Spearman: intelligence involves 2 factors. 3 primary mental abilities. Thurstone: different mental activities depend on certain basic abilities called primary factors. Example: one student may be good at remembering words, another may be better at solving puzzles, and someone else may be quick with numbers. These abilities led to special tests that check skills like memory, reasoning, or number ability. A student may be very strong in solving mathematics problems, abstract learning, but struggle when it comes to making friends or handling social situations. Social relationships. This shows that intelligence is made up of different abilities that may not all develop equally in the same person. G-factor. General intelligence. This is like the overall mental energy that helps in all kinds of learning and thinking. S-factor. Specific ability. This is a special skill in a particular subject or activity. A student may have good general intelligence, G-factor, so they can learn most subjects. But they do especially well in mathematics because they have a strong S-factor in numerical skills. Another student may understand concepts quickly because of G-factor, but they show a special talent, S-factor, in music, like playing an instrument better than others. Someone with good G-factor can learn languages easily, but their S-factor may make them particularly skilled in English grammar. So, G-factor helps in all subjects, and S-factor makes a person strong in one specific subject or skill. Measurement of intelligence. Intelligence tests were first used to find out which school children needed special types of teaching. Later, these tests also help to study how adults differ in their abilities and why their performance is not the same. Binet test of general intelligence noted that intellectual capacity increases with age. Mental maturity is reached between ages 14 to 18, generally accepted as age 15. Mental age represents the degree of intelligence exhibited by an individual relative to their age. Group X. Children. In school, an intelligence test may show that one child learns better with pictures while another learns better with numbers. Teachers can then use different teaching methods for them. Adults. In a workplace, tests may show that one person is very good at problem solving while another is stronger in communication. This helps assign them the right kind of jobs. Intelligence quotient, IQ. William Stern developed a method to quantify intelligence by dividing mental age by chronological age. For adults, the Wechsler-Bellevue Adult Intelligence Scale is used, where the final score is calculated from total points rather than mental age values. Intelligence categories. Category IQ range: genius 170 and above, very brilliant 160 to 170, brilliant 150 to 160, very superior 140 to 150, superior 130 to 140, very bright 120 to 130, bright 110 to 120, average superior 100 to 110, average inferior 90 to 100, dull to mental defective below 90. These categories help classify individuals based on their intellectual capabilities. Though modern psychology emphasizes multiple forms of intelligence rather than a single score. Factors affecting intelligence. G. Brown identified numerous factors that directly or indirectly affect intelligence and shape individual behavior patterns. Heredity. Environment. Newman concluded that variations in intelligence are determined approximately 68 by heredity and 32 by environment. Age. Intelligence peaks around age 20 and remains stable until around 70 years, when it typically declines due to reduced physical efficiency. Health. Physical development. Physical and physiological conditions directly impact mental activity and intelligence levels. More factors affecting intelligence. Race. Culture. Race itself has no direct influence on intelligence, but socioeconomic and cultural factors associated with certain racial groups may affect intellectual development. X. A child's learning may improve or suffer not because of race, but because of access to good schools and resources. Culture influences intelligence by determining attitudes and abilities of individuals. It shapes how intelligence is expressed and valued. X. In some cultures, children are praised for memorizing stories, while in others they are valued for solving problems creatively. Sex differences. According to Crow and Crow, males may show slight advantages in mathematical and scientific concepts, while females often excel in humanities, languages, literature, philosophy, arts. Socioeconomic conditions. Favorable social and economic conditions support better physical and mental development, positively affecting intelligence. More factors affecting intelligence. Race. Culture. Race itself has no direct influence on intelligence, but socioeconomic and cultural factors associated with certain racial groups may affect intellectual development. Culture influences intelligence by determining attitudes and abilities of individuals. It shapes how intelligence is expressed and valued. Sex differences. According to Crow and Crow, males may show slight advantages in mathematical and scientific concepts, while females often excel in humanities, languages, literature, philosophy, arts. Socioeconomic conditions. Favorable social and economic conditions support better physical and mental development, positively affecting intelligence. Intelligence in agricultural extension. Understanding intelligence has significant implications for agricultural extension work. Intelligence patterns vary based on environmental demands and training received. Intelligence remains constant when conditions, health, education, situation, remain constant. Individual differences in intelligence can be attributed to both heredity and environment. Practical applications in extension work identify gifted individuals. People with higher intelligence can be better utilized by offering broader opportunities in programs for accelerated growth. Support those with challenges. Identify mentally challenged individuals in rural communities and provide special attention when training them in agricultural technologies. Tailor teaching approaches. Extension workers can increase effectiveness by using appropriate techniques for farmers with different intelligence levels. These applications help ensure that agricultural knowledge reaches all members of the community effectively, regardless of their intellectual capabilities. Case study. Abstract intelligence in farming. Problem recognition transfer. A farmer with high abstract intelligence can identify iron deficiency in sugarcane based on yellowing leaves and stunted growth. When similar symptoms appear in rice crops, they can transfer this knowledge to diagnose the problem. Extension approach. Extension workers can build on this ability by teaching underlying principles rather than just symptoms, enabling farmers to apply knowledge across different crops and situations. Case study. Mechanical intelligence in farming equipment operation. Farmers with high mechanical intelligence master equipment operation quickly, performing tasks like spraying more effectively and efficiently. Maintenance repair. These farmers can troubleshoot equipment problems, perform basic repairs, and adapt tools to specific needs. Innovation. They often develop creative solutions using available materials, improving farm operations through practical innovations. Case study. Social intelligence in farming. Farmers with high social intelligence excel in community organization, leading farmer groups, cooperatives, and community initiatives. Knowledge sharing. Effectively communicating new techniques to peers and serving as informal extension agents. Conflict resolution. Mediating disputes over resources like water and land. Key takeaways for extension workers. Assess intelligence types. Recognize the different types of intelligence among farmers to tailor your approach. Customize training. Develop materials and methods that address various learning styles and intelligence levels. Leverage local talent. Identify and empower gifted individuals to become community resources. Be inclusive. Ensure those with intellectual challenges receive appropriate support and training. Improve environment. Work to enhance the environmental factors that support intellectual development. Understanding intelligence helps extension workers create more effective programs that reach all members of agricultural communities, ultimately improving adoption of new technologies and practices. Thank you.